Continuing where we left off, so we have reduction of order. Given the ODE, we had our first homogeneous solution. We guessed our second homogeneous solution, which was v times y1. We were able to get down to a new differential equation for v, and really all we have to do now is integrate. There is an integration by parts here, though, so let's go ahead and get into that. So this is a constant, and we have, if I multiply the e to the negative x in, I get x e to the negative x, and then I get minus e to the negative x. Alright, so what I want to do is I want to integrate the prime dx equals integral constant x e to the negative x minus e to the negative x dx. So the integral of e to the negative x, that one's not that bad, but I do have to do a integration by parts for the x e to the negative x. Let's go ahead and do that one. So let's go ahead and stop that. Because I already used the letter v here, I'm going to use a and b for the integration by parts formula. So I have a b prime equals a b minus integral a prime b. And so I'm trying to integrate the x e to the negative x term dx. Okay, well I'm going to pick then my a is equal to x and my b prime is equal to e to the negative x. All right, so then ab prime equals ab, so x, I have to integrate e to the negative x. That ends up being negative e to the negative x. And then I have my minus integral a prime b, so derivative of x is 1. And I have my b already, which was negative e to the negative x dx. All right, so now I have a formula for this. Let me go ahead and move that up here. So integral x e to the negative x dx equal to, okay, I can simplify that, so it's negative x e to the negative x e to the negative x. All right, and then I have minus minus, that's going to be a plus integral e to the negative x dx. Okay, I can do that one, so that ends up equaling negative x e to the negative x. The integral of e to the negative x is negative e to the negative x. All right, so we were able to do that, so now we have an integral. So we have integral of v prime dx equals integral of a constant times, where it go, x e to the negative x minus e to the negative x dx. Okay, well now that's v of x equals, okay, I've got my constant here, and let's go ahead. So we figured out x e to the negative x integral ended up being this thing. So negative x e to the negative x minus e to the negative x. That's all from the x e to the negative x integral. I also have to integrate e to the negative x. So that actually ends up being, I have negative negative, it ends up being minus negative e to the negative x. And one more parenthesis. And to do things correctly, I want my plus d, just to be careful. But that actually simplifies to c times, these actually cancel. So I'm actually going to write this as negative c x e to the negative x plus d. All right, so it turns out it looks like the x minus 1 e to the negative x, you could have integrated it pretty quickly. But here we go. So now we finally have v of x. And here, let me just go ahead and absorb that negative into the c. So c x e to the negative x plus d. All right, then from there, we don't care about what v is. We really care about what y2 is. And v was just a way to get y2. So y2 was equal to v times y1, which here we get c x e to the negative x plus d all times e to the x. And if we multiply that out, we end up with cx plus d e to the x. And that's almost exactly what we would normally write for the homogeneous solution. All right, we already have this one, this piece. That's y1. So we're going to choose y2 is equal to the new unique function, which is this x, right? X is not e to the negative x. Those are very different functions. So we're just going to choose our y2 as x to make things a little cleaner, get rid of some constants. So in our homogeneous solution, y homogeneous, right, c1 y1 plus c2 y2 equals c1 e to the x plus c2 x. And we're done.